Okay, one of the most complicated things about modeling COVID-19 is there's a lot we don't know. Okay, so let me make a Venn diagram here, and I'm going to give it a porous border. Okay, these dashes represent that I really don't know. Okay, so this is going to represent all infections. I'll put over time. So it's not just the people who are currently infectious, it's everyone who has been infected. Okay, so in our model so far, we know that a couple of things could happen. Okay, we know that eventually you're removed, but you could be removed by recovering, or you could be removed by dying. Okay, but what I want to look at here, I'm going to put a big number of people in the infection pool, probably it should be most of it, will in fact, let me actually write this out here, will in fact recover. Okay, so that will be the final outcome for a lot of people, right? Another key thing here, though, is there will be hospitalizations. And most people will recover without being in a hospital, but some need to go to the hospital in order to recover. So let me kind of draw this like that, okay? Actually, probably I should make this part smaller. Let me just start over. You put a small portion outside of the recovered zone and a larger portion inside. Get to the hospital, usually. Okay, and those who are in this zone, this is good. You recover, okay. Over here, this is bad. You don't recover, all right? So this section would be deaths, all right. Now we're going to make some assumptions in our model. Okay, so the problem is we have no idea what percentage of people, well, we have some ideas, okay, but the numbers range pretty widely on what percentage of the population needs to be hospitalized. So I'm going to go with the number that 5% of people who become infected need to be hospitalized, right? I'm also going to use the number that if people get proper treatment once they get to the hospital, 80% of them end up being recovered, but 20% do not. Okay, so it's a high mortality rate for those who have to go to the hospital, but it's much better, more survive than don't. If those same people didn't go to the hospital, probably a large percentage of the 80% wouldn't make it. In fact, we're going to assume later that none of them would make it without hospital care. Okay, so you can see 5% of the population needs to get to the hospital, but how many of them actually die? Okay, so deaths. Okay, it's 20% of 5%. Okay, so 5% had to go to the hospital and 20% die. Okay, so that's 0.20 times 0.05, which is 0.01, okay, which is 1%. So our death rate, if there's proper hospital care, will be about 1%. Let me continue. If we, however, don't have enough hospitals, those who don't go to the hospital, let's just go to the extreme. If there are no hospitals, okay, then the deaths would become 5%. Okay, because all of those people who needed to go to the hospital would die. Okay, so that would be a far worse case. Okay, so if we're looking at numbers in New Jersey, if by the time 1,000 people had died in hospital care, that's 1,000 out of 9 million. Actually, let's make this easier. Let's say 900 out of 9 million. That's, let's see how many decimals am I dividing by. That's 9 times 10 to the 2 over 9 times 10 to the 6. So that's 1 times 10 to the negative 4, or 0.0001. Okay, so 900 deaths would be 0.0001. 0.01. If, on the other hand, we didn't have hospitals for those people, 5 times as many people would have died, and that would be 4,500 people. So while these numbers look really small, it's a very small um, proportion of the population, that is, a fairly large number of people who would have died. And if this had been 0.0005, that would lead to 4,500 deaths at that same point. We've now exceeded that number, but if we didn't have hospitals to care for people, we probably would have 5 times as many deaths. All right. So the key is, early on in the virus, there was a very big concern about whether we would have hospital capacity to take care of people or not. Okay. So as we go forward, we need to explore what happens if we can stay under our hospital capacity versus what happens if we go over the hospital capacity, because public health experts are extremely concerned about which of those two scenarios we are operating under.